Hello, class. Today we're going to talk about transversals and angles. First, we do have a little bit to talk about here, talking about parallel lines, skew lines, parallel planes. Two lines that do not intersect are either parallel or they're skew. All right. If they are on the same plane, if they're coplanar, then they are parallel. All right. And this is what most people think about when they think two lines that don't intersect. Okay. So, for example, line N and line M are parallel lines. Notice here it's got these two little lines in between M and N. Those two little lines there mean parallel. So that's how we read that. M is parallel to N. Okay. Now, two lines that are not on the same plane, lines that are not parallel and do not intersect, are called skew lines. For example, line K here is not parallel to line M, but they'll never intersect. Okay. Another good example of this would be if you look behind me, you've got that little bar right here, this cape, this whatever thing that holds the cords for my computer stuff, and this line on the ceiling right there, they're not parallel, but they'll never intersect. All right. Those are called skew lines. All right. So there's that. Two planes that never intersect are also parallel planes, and we can specify plane T parallel to plane U. Notice, again, planes use capital letters, lines use lowercase letters. All right. And line K and N are intersecting. We don't have a plane shown there, but there is a plane that contains those two lines. All right. Another thing that you'll notice here, on line N and M, we have these two little arrows. That means that those lines are parallel to each other, okay? If you have two lines that have these little arrows, it means the lines are parallel. If you have two other lines that are parallel to each other, you put two arrows on them. These are a lot like those congruent tick marks, right? If they have the same marking, they're congruent. If they have the same arrows, if the arrows match up, then they are parallel. All right, so I did want to talk about that briefly. Now let's get into transversals. But before we talk about transversals, we have to know what a transversal is. So let us write down the definition for a transversal real quick. And we'll just, all right. So a transversal. What this is just a line that goes across two other lines. All right. Now, it could be lines or it could be segments. Either way, it's if you have a line or a segment that goes across two other lines or segments, you have a transversal. So let's draw a picture. Things always make more sense if you have pictures, right? Everything's better when it's illustrated. So let's just draw two lines. There we go. Two lines. They could just as easily be segments. You could have one of them a line, one of them a segment. Doesn't matter. Let's just call this one line A, and we'll call this one line B. And then we need a transversal that goes across them. So, for example, just like this, here we go, and we can call that one line C. So what we have here, line C is a transversal of A and B. All right, and that's just, so it's a transversal just because it goes across it. Note, I use lowercase letters for the lines. All right, now, when you do this, every time you have a transversal, it's going to create angles, and it always creates 8 angles, 4 on each line, right? So at this intersection of A and C, we have an angle. We have angle 1, actually, you know what I'm going to, yeah, whatever, angle 1, angle 2, angle 3, angle 4. And then over here we have it again. So we have angle 5, angle 6, angle 7, angle 8. All right. Every time you will always have 8 angles formed, and those angles have special relationships. All right. There's special qualities that they could have, but they have a relationship. So we're going to talk about that real quick. The relationships formed by the different transversals. All right. So first, the angles could be corresponding. Corresponding angles are in the same position. All right. So for example, angle 2 and angle 6 are both in the top right position. All right. Also, I could have, for example, angle 1 and 2, 3, 4, 5, angle 5, both in the top left position. So angle 1 and angle 5 are also corresponding angles. Okay, so I'm going to note that down. Angle 1 and angle 5 are also corresponding angles. The same could be said of, let's see, that would be 3 and 7 and 4 and 8, all corresponding. They are in the same position. Okay, another thing we could say, we could have alternate interior angles. And we're going to talk a lot about alternate and consecutive and interior and exterior. Alternate, what that means is the two angles are on different sides of the transversal. So notice angle 4 is on one side of the transversal, angle 5 is on the alternate side of the transversal. So those are alternate angles, okay? Interior means that it is inside the two lines that are being crossed by the transversal. So interior means it's inside those two lines, exterior means it is outside the two lines. So here, alternate interior angles, we have 4 and 5. They are inside those two lines, and they are on opposite sides of the transversal. Another example, see this 1, 2, this would be 3 and 6 are also alternate interior angles. Would be another example, angle 3 and angle 6, alternate interior angles. So if we have alternate interior angles, we also have alternate exterior angles. All right, so that's what we have down here. Notice they are on different sides of the transversal. Angle 1's over here, angle 8 is over there. And they are on the outside of the two lines that got cut by the transversal. All right, so we have angle 1 and angle 8 are alternate and they are exterior. Okay. Also, this would be angle 2 and angle 7 are also alternate exterior. Well, that's if they are on alternate sides of the transversal. What if they are on the same side of the transversal? Well, if they are on the same side of the transversal, again, you look at, are they interior, are they exterior? So 3 and 5, you'll see, are between the two lines that are being cut. So they are interior angles. They are on the interior, and they are both on the same side of the transversal. And so what we call these is consecutive interior angles. Remember, consecutive means one right after the other, like 1, 2, 3, 4, 5. Consecutive numbers. These are consecutive angles, one right after the other. Now, there is something else you could call these instead, and a lot of books will, and these could also be called same side interior. So I'm going to write that right here. All right, same side interior, because they're on the same side of the transversal. We do have another example of this, of course, which would be angle 4 and angle 6. Also, same side interior. They are on the same side of the transversal, and they are inside the two lines that got cut by the transversal. All right. So on these three different types, there are two pairs every time you have a transversal. On corresponding angles, however, all 4 of the angles on the top will have a corresponding angle on the bottom. Now, there is one other angle relationship here from transversals, which for some reason my book doesn't include, but I'm going to give it to you anyways. And so let's pull up this picture that we just drew over here. And that would be, what if the angles are on the same side, but they are outside of the two lines being cut? Well, if they are on the same side, we can call them same side. And if they are on the outside of the two lines, we will call them exterior. So these would be same side exterior angles. We will not call these consecutive exterior angles because they're not next to each other. They've got consecutive exterior angles because they've got those interior angles in between them. So they're not consecutive. They are, however, same side. So that's what we will call them. And the definition for this, we will say that these are angles on the same side of the transversal and outside the two lines. An example of this would be angle 1 and angle 6. Or we could also go on the same side, the other side of the transversal, we have angle 3 and angle 8. Also, same side exterior angles. I do not know why those aren't in the book, because they are a thing, and we will be using them quite a bit. We do have two other postulates to look at really quickly here. The first one is the parallel postulate, which says that if there is a line and a point not on the line, then there is one and only one line through that point parallel to the first line. So, for example, there is only one line through point P that is parallel to line L. Because if I had another parallel line, or just whatever, and I moved it over a little bit, well, that's great, it's parallel, but it's not on point P, is it? It's up above it, or it's down below it. If it goes through point P and I try to make a different line, that means I have to turn it a bit, and if I turn it even a little bit, now it's going to intersect way down here, right? Or if I turn it the other way, now it's going to intersect way over here, so it's no longer parallel. Okay. The perpendicular postulate says that if there's a line and a point not on the line, there is one and only one line through that point perpendicular to the given line, right? So this is the only line perpendicular to line L that goes through point P. Because if, again, same kind of thing. If it's perpendicular, in order for it to be a different line, I've got to move it over. Now it's not going through point P. Or if it goes through point P, I'd have to turn it a bit to make a different line, and now it's no longer perpendicular. Okay? All right. So let's do a couple examples using all of this. So in exercise 1 through 4, we want to think of each segment in the diagram as though it's part of a line. So instead of being segment FG, it's line FG. Instead of segment GB, think of it as line GB. Which lines or planes contain point B and appear to fit the description? So we are specifically looking only at point B. So I'm going to mark it so I can find it easy. There it is, point B. So we need a line skew to line FG that is going through point B. Okay, well, we've only got 3 lines that go through point B, right? We've got AB, we've got BG, we've got BC. That's it. So which one of those would be skew, which means that it's never going to intersect, but it's not parallel. And it's just which one appears, so we're not going to have to worry about proving that they're parallel or not. Which one appears that way? Well, BG obviously intersects and skew doesn't intersect. AB looks like it's not going to intersect, but it's also not it is parallel, which means it's not skew, which means we're going to go with line BC. Okay, so now we want a line that goes through point B still that is perpendicular to FG. So that would be over here, BG, because we see that it's marked with a right angle, so BG. And let's see, 3, we want a line parallel to FG that appears to be parallel. We're not going to prove it right now. That goes to point B, and that will be the only other line that goes through point B, which is AB. It does appear to be parallel to line F. All right. Now, which plane is parallel to plane FGH? So FGH, that would be the back side of this prism, right? Back here. So which plane, still containing point B, would be parallel? Well, that would be ADC, right? The plane that is on the other side of the prism that appears to be parallel, they're not going to touch. And there's not a symbol for that, remember, so we have to write this out. Or you could call it ABD or ADC, whichever one you call it. So let's take a look at these down here. We want to identify all pairs of angles of the given type. And for some of these, that's going to be a lot. So corresponding angles. Every set of corresponding angles. Well, let's just start with angle 1. Right? What does angle 1 correspond to? Angle 1 is going to correspond with, well, we've got a couple of different things. Because remember, a transversal is a line that goes across 2 other lines, right? Well, I've got that line going across 2 other lines. I've got that line going across 2 other lines. And I've got that line going across 2 other lines. So I've actually got 3 sets of transversals on here. And each one creates 8 angles. For each set of transversals, we're going to have 4 corresponding angles, 4 pairs of corresponding angles. So if I just look right here, let me get something to cover that up. Makes it easier if you cover up the ones you're not looking at. So I'm not looking at that in a second. I just want to look right here. So here, angle 1 is on the bottom, and it's over there on the left. So bottom left, let's see here. So that would be angle 5. So angle 1 and angle 5. All right. Now, if I look this way, angle 1, still on the bottom left, corresponds with bottom left-ish kind of thing, would be angle 9. So angle 1 and angle. So angle 1 and angle 9. If you'll notice, though, if I look at 5 and 9 going this way, do 5 and 9 correspond to each other? Well, no, because 5 is on the outside over here, right? Kind of bottom. Well, that's kind of weird looking, isn't it? Turn it. There we go. I find it's easier if you have your transversal going vertical. So here, going this way, 5 is on the top, 9 is on the bottom. Those are not in the same place, are they? No. So 5 does not correspond to 9, even though both of them correspond to 1. Okay, so let's just keep looking over here. Let's look at angle 2. Okay. So angle 2 corresponds, again, it helps put vertical like that. 2 is on the top, so on the top, on the same side of the transversal, would be angle 6. Angle 6. Let's go ahead and do the rest of them. So angle 3 would correspond with angle 7. Angle 4 corresponds with angle 8. So that takes care of that transversal. Let's keep using 1, 2, 3, and 4. So let's look this way. If you have transversal going horizontal, that makes it easy too. So we already did 1, so let's look at 2. So that'll be 2 and 10, 4 and 12, 3 and 11. All right. So we've now taken care of that transversal, and we've taken care of that transversal. We need to take care of this transversal. All right. So let's see here. On this transversal, we have 6 is in the top right, so that would correspond with 12, also in kind of sort of the top. It's a little hard to see when the lines are going at an angle like that, but still in the same basic position, right? So angle 6 would correspond with angle 12, angle 5 with angle 10, angle 7 with angle 9, and angle 8 with angle 11. So we have all of the corresponding angles, and there are a lot of them, because each angle corresponds with an angle on both transversals, right? So since we have 12 angles, we have a lot of pairs. Now some of them overlap, but still. All right, so that is corresponding angles. Remember, they have to be in the same position, and each set of lines, each transversal, is going to create 4 pairs of corresponding angles. All right, now let's look at alternate interior angles. Again, let's just do this one transversal at a time. So let's look at that transversal first. So alternate interior angles, remember, they have to be on opposite sides of the transversal, and they also have to be inside the 2 lines that are getting cut. So we're going to the ones just on the inside, so we're looking at these lines here. So there's those 4 angles, that's it. 5, 7, 2, and 4. And we want them on alternate sides of the transversal. So 5 would go with 4, opposite sides of the transversal. And also over here we'd have angle 2 and angle 7. Okay, so that's this transversal. Let's do the top transversal, why not? Cut that one out, let's just do this one going across this way. So let's see, only on the inside, because we want alternate interior, so that would be just these 4 angles, and they need to be on alternate sides of the transversal, so 4, and across that we have 9. And then 3 and angle 10. Okay, so we need one more, and that would be this one. And how about if you pause the video and you name the alternate interior angles for this transversal. All right, let's see how you did. So we want interior angles, so we want to look at the stuff on the inside, so that's 7, 8, 10, and 12. And we want alternates, so let's see, 7 would match up with 12 on the other intersection. Angle 8 would match up with angle 10. And that is one very important thing. On all of these, you will have one angle from each intersection. All right? Each intersection has 4 angles, and you're going to have one angle from each intersection. So let's look at alternate exterior. And we're already on this one, so let's just use this one first. So exterior, we want the angles on the outside of the two lines. So over here we want 5 and 6. Over here we're looking at 9 and 10. Oh, sorry, 9 and 11. And so let's angle 5 is going to match up with one of them. It'll be the one on the opposite side of the transversal. So that would be number 11. And then 6 with 9. So now let's look at this transversal. So now we're looking still exterior, so 6 and 8 up there, and 1 and 3 down here. And again, we want alternates. So if we go with angle 6 to start with, we'll have angle 3 on the other intersection. And then that leaves us with 8 and 1. And once again, I would like for you to pause the video and see if you can come up with the alternate exterior angles for this transversal. All right. So we're looking at the exterior, so we're looking at angle 1 and 2 over there, and angle 12 and angle 11 over here. And they need to be on alternate sides of the transversal. So that gives us angle 2 and angle 11, and then angle 1 and angle 12. Alternate sides of the transversal. All right, next we have consecutive interior angles, and since we're on this one, let's just stay here. Consecutive interior, remember that is the same thing as same side interior angles. So we want interior angles, and they need to be on the same side of the transversal. And they're interior, so we're looking at the ones between the two lines getting cut. So in this case, we're looking at 4, 3, 10, and 9. And we need the ones that are on the same side of the transversal. So angle 4 is on the same side as angle 10. And angle 3 is on the same side as angle 9. And remember, this is why they're called consecutive interior angles, because they're right next to each other, right? There's not another angle in between them. All right, so let's take a look at this transversal. We want the interior angles, so that's 7, 8, 10, and 12. And so we want the ones on the same side because they're consecutive interior angles, so same side interior angles. So angle 7 would match up with angle 10. And angle 8 is on the same side as angle 12. All right, so we have one left, one transversal left. So again, pause the video, see if you can write down the right consecutive interior angles. All right, so let's see here. We're looking at 7, 5, 2, and 4. We want the ones on the same side, so angle 5 will match up with angle 2 because they're on the same side of the transversal. And angle 7 will match up with angle 4 because, again, they're on the same side of the transversal and they're both inside the two lines that are getting cut by the transversal. All right. And so there it is. All right. Very important. Notice on these last three, we have two pairs for each transversal, right? Two pairs for each transversal. Corresponding, they are all going to be corresponding. So you have 4 pairs of corresponding angles every time you have that transversal. The rest of them, you'll only have 2 pairs. All right. Parallel postulate, perpendicular postulate, through any point there's only one line that's going to be either parallel or perpendicular. And don't forget all of our angle relationships. Hopefully you found that useful, and I'll see you in the next video.